Now I will discuss about the manual metal arc welding. In case of manual metal arc welding, we use the electrical power supply, maybe AC power supply, maybe DC power supply, and using that power supply we use the AC source or DC source. It will help to produce the arc between metal plate, and it used to that arc will help to create the and maintain the electric arc between the metal plate and electrode. Then the base material will be melted due to generation of the arc, okay, and at that welding space or at that welding point, okay. Then using that melting of that particular metal, it will help to produce the weld across the welding zone, okay. The power source may be DC power source, may be alternating current source, okay. And sometimes we use in that arc welding, maybe use conjugate electrode or non-conjugate electrode. And sometimes the welding region are protected by the some shielding gas to protect from the reaction of the some weld surface or reaction with the molten metal with oxygen. It will protect due to shielding region in the weld face. Now here we have seen that is the electrode, that part is the electrode, and okay, some coating. Sometimes you give the some flux coating. Why we use the flux coating? That flux will be melted during welding time, means when arc will be generated between two electrode and metal surface, in that time that flux also will be melted, and due to melting of the flux, that will be accumulated across the weld zone, okay. And actually that is the slack zone, means that is the flux zone, okay, that is the flux zone, okay. And that flux zone helps to protect that weld surface from the reaction with oxygen, okay. And actually that is the solidify weld, and that is the globules means that is the arc, means ionized plasma column that will created between the electrode and metal surface, okay. To create the arc between a voltage near about 60 to 100 volts, we have applied to that particular welding operations. And sometimes once it has been established 20 to 40 volts also we have maintained in general cases, and using that volts we create the arc between the metal surface and electrode. Now we discuss the process principle. Here when welding plant switch on, the force before welding commence, no current. Before welding, no current passes through between metal plate and electrode, okay. The ammeter reads at that time, ammeter reads 0, means no current passes, means no, the ammeter shows the ammeter is used to measure the current. So when no current passes means ammeter reading is 0. And when we apply the voltage to that particular circuit, so due to applying voltage, then current will be increases, means increases from 0 to some particular reading, okay, due to application of the voltage, due to application of the potential. Near about we will read the open circuit or no load voltage near about between 60 to 100 volt we have applied in that cases when we provide the voltage. When electrode is brought and just give the switch on, okay, then voltage we apply, then current also increases from reading 0 to some particular point, okay. After that we take the electrode and it will come near to the metal plate. After that the one burning, means arc will be created between that metal plate and electrode. And during welding time, what we can do, now we maintain some particular distance between metal plate and electrode, and between that gap one plasma means arc column will be created. That arc column is generally maybe of air or gas. Okay. And the ammeter will deflect a large amount. When it will come to the electrode to the metal plate, the ammeter will deflect a large amount, means current will be increases, and the voltage drops almost to nothing. Voltage drops is very less, very less, and the tip of the electrode becomes hot, and due to continuous increasing in current, after certain times the tip of the electrode it will be heated. And when it will come to near to the metal plate, at that time the arc will be created, means that is the generated ionized plasma column of the gas or air. Now electrode slightly withdrawn and it is formed between the electrode and, means after testing, means just we touch the metal plate, then arc will be created, means at that time we just do some testing, means it will working or not. After that we withdrawn the electrode, just a distance around 3 mm, means certain distance will be withdrawn, then it will formed, the arc will be formed between the electrode and metal plate. So that welding current, as the arc is formed, the voltage rises between, and voltage at that time voltage rises between 20 to 40 volt, and current also take the some particular value it will be set. Then the arc is then the normal welding conditions, means arc will be generated between the metal plate and electrode, and due to generation of the arc it will help to melt the metal, or sometimes we use some filler material, that arc melt the filler material, and due to generation of the melting of the filler material, it will be deposited, metal will be deposited to the in the oil pool. Okay, and during depositing the oil metal, variation in both voltage and current can occur, means when it will depositing the molten metal, at that time both voltage and current reading may be changed. Okay, so in that time, due to deposition of the molten metal, after certain time it will create a solidified product, and sometimes some flux material, we using some flux material, it will be coated to the electrode. Okay, and that time some flux materials also melted, and that flux material creates one layer on the weld surface to protect with reaction with oxygen. Okay, what are the equipments in manual metal arc welding? First one, welding power source, cables, electrode holder, earth clamp. Generally 4 components are the important in case of manual metal arc welding. First one, that is the manual metal power source, means welding leads, means that is that welding power source, that is the welding power source, it may be AC type, means it has provides the maybe AC current, alternating current, or DC current, and that is the welding leads, it will be connected to the metal and electrode, and for sometimes it will be connected to the earth. And generally 2 types of power source we have used, one is alternating current, another is direct current. Okay, in case of AC power source, directly connected to the main electrical power supply, AC power supply is directly connected to the main power supply. Okay, then it uses a transformer to correct the voltage to suit the welding operations. Sometimes when we connected the AC power source to the main power supply, then uses a transformer for providing the constant voltage for welding operations. Okay, and a special device sometimes we have used. Transformer allows the current in the secondary coil. We use some primary coil and secondary coil to adjust the controlling the voltage. Okay, the primary coil is connected to the electricity power, power supply, the primary coil connected to the electrical power supply and secondary coil connected to the earth clamp. Okay, the secondary coil is connected to the earth clamp and electrode holder. Okay. In case of DC power source, generally we have used DC generator on transformer rectifier. Actually, it will act as a converter. Means it will convert the AC current to DC current. DC generators uses a motor. That motor will be running by electric, maybe petrol, maybe using diesel power. Okay, to generate the electricity. DC generator uses a motor. That motor will be running through using electric or petrol, maybe diesel. Okay, and that will help to creates the DC current for the arc. Sometimes in transformer we use rectifier. Why we use the rectifier? That will basically a transformer with the electrical device for changing that transformer rectifiers helps to convert the AC current to DC current. That is the main function. Main function of the rectifier in the transformer, that will convert the AC current to DC current. This device is known as rectifier. The main function is to convert the AC current to DC current. The transformer rectifier has the advantages is to make the power supply. Means now in at present some transformer has there. It has capacity to change the current AC to DC, and also that transformer also may we use the AC current or DC current. What are the advantages of manual metal arc welding? First one, it is a simplest form of the welding operation, all the arc welding operations. All the equipment may be portable or may be portable in everywhere, and the setup cost also low respect to other arc welding operations. This process in innumerable applications because of the availability of the wide variety of electrodes. Means it has lots of applications. Because what is the cause? Because due to availability of the wide range of electrodes. A wide range of metals means various metals alloy we also can be welded using that manual metal arc welding process. Welding can be carried out in any positions. In any position with highest weld quality. Means in any position, maybe vertical position, maybe horizontal position, maybe inclined position, maybe overhead positions, we easily do the welding using this process and also maintain the better weld quality also. This process is very employed for hard pressing and metal deposition to reclaim parts to develop the characteristics like wire resistance, that things. Means the weld quality is very good in that welding process. So that's why it maintains the very good weld quality and maintain the hard pressing also, and also there no problem like wire tear, that type of things does not happen in that welding operations. Joints between the joints which because of their position difficult to be welded by automatic welding machines are easily accomplished by flux shielded metal arc welding. Sometimes in case of automatic welding that creates some problems. Okay, so that's why we use that type of process in any position. It will help to weld easily. And also sometimes in case of automatic cases, that also welding machines are easily accomplished by flux shielded metal arc welding. What are the disadvantages? Slow welding speed, low deposition rate. Due to low deposition and slow welding speed, the productivity is less. Okay, means the number of weldings, it is not possible in that process due to slow welding speed and low deposition rates. Relatively low productivity means number of welding operation is less. Welding may be contain slag inclusion. Sometimes it has slag inclusion remaining to the welding zone. So that's why the quality, sometimes the quality of the welding also quality of the welding is poor. Continuous welding not possible due to frequent stops required to change the electrodes. Means when sometimes we use the consumable electrodes. When it will consume, then again we change the another electrodes. So due to that things, the continuous welding is not possible due to consume of the electrodes. Significant fumes given off by this process. Sometimes some fumes will be created in that process also. That will be not good for that particular welding process. Now we will discuss the manual metal arc welding. Actually that is the electrode, and some manually we have done that welding process, and using that electrode and some welding power sources is there, and we do the welding across that connected zone. Means two plates are there across the plate surface, means end of the plate surface we are doing the welding. Means that is the manual metal arc, that is the created arc. Continuously electrode are consuming, and again electrode is consuming, then again we have replaced the another electrode for welding operations. Also some cylindrical type parts also we have welded. Some safety they have taken during welding operations, during welding time. Means across these joint they are doing the welding.